This chapter is about carboxylic acid and its derivative. First, we'll have primary alcohol and nitrile to form carboxylic acid. And first of all, this primary alcohol, not weak, they will react with acidified potassium manganate 7 solution or acidified potassium dichromate 6 solution, and they undergo oxidation. In which condition? Well, in reflux. You can just warm it, you can say heat in reflux. And this will give COOH, carboxylic acid. After this, we'll have nitrile. What happens if we use nitrile to obtain carboxylic acid? First, they will undergo acidic hydrolysis through addition of dilute sulfuric acid or any kind of acid, but I will prefer this in this case because they are much stronger than HCl and it will be easier for it to undergo the acidic hydrolysis. Then we'll obtain carboxylic acid. Well, carboxylic acid, they will have other end products. First, we'll have salt. Number 2, we'll have ester. Number 3, we'll have acid chloride. First, we'll have salt. Neutralization. What happens if you have neutralization here? When you have neutralization, this will react with carboxylic acid. They break and give the H and react with the OH over here, and they give the end product of carboxylic salt through neutralization reaction. And carboxylic acid, they will react with alcohol through esterification to give ester. And the arrangement of ester is COO. Number 3, we will have carboxylic acid to form acyl chloride. And this process is called acylation. Acylation comes from this acylation. And how does this react with this? When carboxylic acid, they react with Cl5 and SOCl2, they will give acyl chloride. And remember again, these two reactions, they have to occur when you heat it or reflux. When you heat it or reflux. Yay, so after this, let's study ester. Well, ester, you can obtain the reactant back when you undergo these two processes. First, we'll have acidic hydrolysis. Acidic hydrolysis, you will react it with dilute H+, or just now I have said I use H2SO4, or you can use other like HCl, HNO3, whatever acid that will apply. And this will give carboxylic acid. After this, we'll have alkaline hydrolysis, and we will need this NaOH to react with ester. And this NaOH react with ester to give carboxylate salt. And this is the negative part of COO, because next to here there will be a unseen Na+. I just don't write it because that will be very confusing. But remember, the end product is actually COO and water, H2O. After this, you have dry acid chloride. Remember, you have to add this dry. Only dry acid chloride can react with alcohol to give ester in the arrangement of OCO through esterification. After this, we will have acid chloride to react with corrections here. Ammonia and acid chloride and ammonia. These two undergo condensation, or you can say addition, elimination. These two reactants, they react and gives amide, CO double bond or NH. And if you don't feel like I don't want this amide group, you can undergo hydrolysis with NaOH to obtain COOH and ammonia gas again. And again, this ammonia gas, they are smelly, so remember that the reaction will be a bit smelly and be aware of that. After this, we will have to know the question that commonly come out in this chapter. They will ask us to compare the strength of acid. First, we will include the equation, then the atom and the group. And we will describe the nature of the group, whether it is electron donating or electron releasing. After this, we will see whether they are having this inductive effect or not. Number 5, the stability of the acid. And we see whether the H plus will attach to the R group or it will fall off. After this, the strength of acid. If the H plus can break off easily, the strength of acid is strong.